Based on a lot of the comments that I get on this channel, it's clear that many of you don't understand how to use React hooks properly or aren't getting as much out of them as you could, which is understandable. When I moved from using React class-based components to using functional components with state, the advice was pretty simple. If you had this.state, you use useState. If you had component did mount, you use useEffect. If you had refs, you use useRef. But that's leaving so much of the story out. It would be like Thanos saying, when I snap my fingers, housing prices are gonna become so much more affordable, which is technically true, but leaving so much of the story out that you need to know. Of course, in our case, the story that was left behind in that oversimplification is a really good one. It's one of reactive state management. So to learn that, we are going to port this Pokemon spreadsheet to the web. Now that Pokemon spreadsheet has first 3 columns of biographic information about each Pokemon. It's got 6 columns of statistical information about each Pokemon, and that came from the original service. And then the spreadsheet adds on a power ranking, which is just a summation of the statistics, as well as a min and max. And we want to bring all of that over and add on top of that some filters. Now, if we were to do that using our traditional tooling, we would flatten it. We would have the original Pokemon array from the service. We'd have a derived Pokemon table that would have the additional power ranking, and then we'd have min and max and the filter settings. But that loses the dependencies that we had in the spreadsheet. We know that in the spreadsheet, if we changed a value in the statistics, the power ranking would change and the min and max would update. And that's because there's a dependency graph built in to the spreadsheet. It's why we love spreadsheets. So can we retain that dependency graph? Can we look at the world as values, as nodes in a dependency graph where when one changes, the others change automatically? We've been thinking about that in terms of new state managers like RxJS and Jotai and Recoil and to some extent MobX, or in different frameworks like Vue 3 or Svelte or Solid.js. But did you know we can do it in React using just the hooks that we have today? We don't know that because we oversimplified them, but let's rediscover that in the office right now. Okay, we're back in the office and we're looking at the code that is included as a link in the description. And there's also a code pen that you can start out with as well. It's exactly the same thing. Now here's that spreadsheet that we were talking about. It's got the first 3 columns that are the biographic information on the Pokemon, 6 columns worth of statistics, that power, and then the min-max. And we're gonna go and add on an additional couple of things. We're gonna go and add on a search system. It allows us to just quote quickly find by name. And then also a threshold system that allows us to give the count above a certain power threshold. So let's jump right into it. Okay, so here's our app. And this is the app.tsx, and everything is pretty much in here, bringing in React, as well as useEffect, useState, and useMemo, because we're gonna be using those a lot. And also we have an API that gives us all of the Pokemon or just the Pokemon by a particular name. We'll use that for that search ability. And then we got a calculate power. That's just so we don't have to type it all out. There's a Pokemon table component that renders the Pokemon. We'll be using that soon. And here's our app. Along the top, there is the search and the power threshold inputs, as well as a count over that threshold, and then the Pokemon table, which is currently empty, and the min-max. Let's go take a look at it in the browser. And you can see it right here. So here's our search field. Here's our power threshold. This is going to give us a count over that threshold and so on and so forth. So let's try it out. Let's go and first load up all of the Pokemon. And the first thing we're going to need to do there is start up Pokemon like that. By the way, that awesome hinting was from GitHub Copilot, which will be helping us along as we go. So I'm going to go and define this as an array of Pokemon. And we're pretty used to that. Use state. Let's do a useEffect to load that up. And there we go. We're going to give it an empty dependency array, which, as we all know, means component did mount. And we'll call getAll. And then with that data that comes back, we'll just fire that off to set Pokemon. And there you go. And then we'll grab this Pokemon and drop it into Pokemon here, into that table. I'll hit save. And there we go. So a pretty good start. So now we want to go and add on that power value. And first I need to define a new interface for that. So I'm going to say that we have an interface called Pokemon with power. And it's going to extend Pokemon. And it's going to add on a power, which is a number. right? That's going to add an additional row, and we'll go and make the Pokemon table look at Pokemon with power instead. And then we'll just go and add an additional column, power, and we'll then put it into the data as well. Power, so there you go. Okay, cool. Now we actually have to go make it. So I'm going to do this without useMemo. And there's a good reason for that. I want to show you why useMemo is so important. People keep on asking me over and over and over again, do I need to use useMemo? Do I need to use useCallback? I'm going to prove it to you right now. Okay, so first off, let's just go and do it without useMemo. So I'm going to say Pokemon with power. And it's just going to be Pokemon.map. And we're going to take a Pokemon and return it. So all of that. And then we're going to give it a power, which would be, we'll use calculate power to do that. Thank you, GitHub Copilot, for that. And that looks good. Okay, so now we need to pass that on to our component. Cool. And let's take a look in the browser. There we go. We got our power. That's awesome. Okay, so what I'm going to do next is I need a way to show that app is rendering and that table is rendering as well. So I need something in the app that's going to force a render of the app. So I'm going to go and implement this power threshold. So again, I will use a count over threshold like this, and it will take the Pokemon with power and then filter that so that the power is above some threshold, and then we'll get that. And so we need to actually store that threshold somewhere. So we need to go and create a new threshold value. And nice hinting on that. Thank you, GitHub Copilot. So then we'll add that on to our input field. And also on change, and that's going to on set threshold. And this one's going to take an event. And I'm not going to use useCallback for this one either. We'll get there. So then we'll do set threshold and give it the event target value. All right, now I messed up over here. I just need to add on Pokemon like that. So we need to fix that. That's a React change event on an HTML input type. And then we also need to parse that integer with a radix of 10. Nice. And the last thing we need to do is then go and add in count over threshold right here. Cool. Okay, so now we're starting at 0, and I'll say 500, and there are 189 Pokemon that are over 500. Cool. Awesome. So I need to track how this is rendering. So I'm going to go and add on a few things here. I'm going to say app render and just give it a 0. And then we're going to do a console log every time app re-renders. Console.log. Say app render equals, and then just get app render, and we'll do ++ on that. So every time it'll just go up by 1. And then I'll do the same thing over on table. So I'll create one called table render. And we'll say table render. And there we go. Okay, cool. So we'll bring up the console and we'll see how we're doing. Okay, so now every time I change this, we're getting both an app render and a table render. And theoretically, we should not see a table render, right? Because the table actually isn't changing at all. So maybe it's memoization. Maybe that's the problem. Let's do React.memo on the table and see if that helps. So we'll go and grab Pokemon table here. We'll create a new constant called memoed React table, and then just call React memo on that. And now we've got a memoized table, which we can then replace with Pokemon table. Now let's take a look. Has that now improved anything? So clear this out, change that to 502, and no, that hasn't fixed anything. We're still getting both a table render and an app render. And why is that? Well, React memo works effectively on triple equals. So any property is going to be triple equal compared against any other property. And let's take a look at what you do, what you get when you have two arrays and you triple equal compare them. They're not the same because the references are different between the two. If I were to say, for example, const a equals and then an array, and I would say a triple equals a, that is true. But just a random new empty array is not equivalent to another new random empty array because the references are different. So we need to maintain referential integrity. And this is what Kent C. Dobbs is talking about in his article. So how do we do that? Well, we use useMemo, and that's why useMemo is so important. And it's actually pretty easy. Let's try it out here. So let's do useMemo. And the only thing we need to add is this dependency array. And the dependency array has whatever we use for that calculation. So in this case, that's Pokemon. We drop that in there. So what we're saying is, at this point, anytime Pokemon changes, then this is going to change, and there's going to be a trigger there, which then in turn runs this function that's specified by useMemo, and that's going to regenerate Pokemon with power. Okay, so let's try it out and see if it works. Awesome. Okay, so now we are seeing a different count over threshold, but we're not seeing any new table renders because the reference to Pokemon with power doesn't change. When useMemo doesn't fire because Pokemon doesn't change, then Pokemon with power isn't updated and doesn't create a new array, which creates a new reference, which requires memoization. So let's go change count over threshold to also be a useMemo. And cool, GitHub Copilot has looked at our function and decided that we have Pokemon with power as a dependency as well as threshold. So we're starting to see how this works. We're starting to get a cascade. So Pokemon creates Pokemon with power because it changes when it starts up. And then Pokemon with power, in turn, is part of the dependency set here, and it's merged effectively with threshold. So when either Pokemon with power or threshold changes, then automatically count over threshold is updated based on that useMemo. So really easy, and it's a great way to create those dependency connections. So useMemo is just a weird name for that function. It puts the emphasis on memoization, which puts the emphasis on performance. In Vue 3, in their reactive API, they actually use the term computed, which makes a lot more sense. Of course, we're going to use computed when it comes to count over threshold. Of course, we're going to use computed when it comes to Pokemon with power. But memoization seems like an optional performance optimization. So just when you think about useMemo, think about that this is a computed value. Okay, so the next one we want to do is replace this with useCallback. That's what you do when you need a callback. And it's exactly the same API surface, because you're returning a callback as opposed to a function, and as opposed to some data. So I'm going to go and add on there. What is that dependent upon? Well, that in this case is not dependent on anything. So we're going to add useCallback up here. Great. Cool. Fix that, and looking good. Okay, great. So let's continue on. Let's actually do min and max and see how quickly we can pull that off with this useMemo, again, which is the calculation. So let's do min first. We'll use memo. And I'm not going to redo it like this. Thank you, GitHub. But I'm going to pick my own route on that one. I'm going to say math.min. And then destructure an array, which is the Pokemon with power map, where I just grab out the power. Big fan of reduce, but not in this case. Okay, and I'm also going to depend on Pokemon with power, just like that. All right, let's try that out. So we get 175, that's the right number. We'll do the same thing with max. Perfect, 720, awesome, great. Okay, so the last thing I want to implement over here is the search. And it's pretty easy. We just need to first get a search value. Great. Okay, cool. And now we want to pass that into this useEffect. So we're going to do get by name as opposed to get all. And then we're just going to add search in there as the name. And then we're going to make that dependent so that anytime search changes, and then I need a way to go set that. So let's go down here to the text field, put in the value like that, and then an on change again, on set search. Just copy that, call it on set search. And in this case, we're going to set search, but we're not going to parse it as an integer. Okay, looking good. And no dependency array because, again, it doesn't depend on anything. All right, let's try this out. BU, cool. So check this out. So we've gone and added a search field, and there's some really cool secondary effects from this. So I changed this to bull, and that has pared down the list to just these two Pokemon. And so over the power threshold of 0, we get 2, right? And this just automatically happens because of the dependency graph that we've created through these dependency arrays and these useMemos and these useCallbacks. So let's go back into our editor and create a diagram and just diagram it all out. Okay, so I'm going to go over here to general, grab a box, and that's going to say Pokemon. And Pokemon is dependent on search. So we'll draw arrows from the dependent to the depender, I guess. So then there's Pokemon with power. And it in turn is dependent on Pokemon. And then there's min and max, and they're dependent on Pokemon. There's also the threshold value. And then there's count over threshold. And count over threshold is dependent on threshold and also on Pokemon with power. And so now you can see how these connections change. For example, when threshold changes, only count over threshold changes. When Pokemon with power changes, then count over threshold would change as well as min-max. And it just flows naturally. And of course, when search changes, everything relies on search in some way, but you're not specifying that over on count over threshold. Count over threshold just knows that it depends on Pokemon with power. And so you're creating this awesome dependency graph that makes it so that you can look at each one of these things absolutely in isolation and test them in isolation. And that's how we create a dependency graph using just the basic toolkit of useEffect, useMemo, useState, and useCallback. So before you go on your journey to understanding reactive programming in React using just the basic hooks, a few rules of the road for you. First off, there are some linter rules built into ESLint that are specific to dependency arrays. You should keep those enabled, and when they go off, make sure to understand why they're going off and remedy that. The second one is to watch out for useEffect. Asynchronous actions in useEffect can be really tricky. And if you have a dependency on the same value you might be setting within the useEffect, that can create some loops. And that's not great either. And of course, the third thing I want to talk about is to re-emphasize useMemo and useCallback. If you want to build custom hooks, you'll want to use those to maintain that referential integrity. I have added a link to Kent C. Dobbs' counterposing article in the description, and you can be sure to read that and get the other point of view as well. In the meantime, of course, if you have any questions or comments, be sure to put those in the comments section down below, and hit that subscribe button if you like this video, and hit that bell, and you'll be notified the next time a new one of these comes out.